Hi, my name is Selina Daley. My student number is 100558926.
Hi, I'm Stephen Richards. My ID number is 100-458-273.
This is Gerin Puig, student ID 100656910, and when we're talking about our assignment, and to start it off, Selena will talk about the command design pattern.
Okay, so for our command design pattern, we decided to implement it for our user when they're going to change key bindings. So here we have our, okay, so it's showing on the screen. So reset all keys and, oh, are you switching to the,
Yeah, I'll switch.
I'll leave it with, okay, switch. Okay, so reset all keys and change keys are both inherited from our command abstract class that we have here. And they're both concrete commands. Our input request is the receiver. And over on our C# side in Unity is our invoker. So we decided to use the command pattern because it's useful for when you're doing multiple requests, such as updating different key bindings. So if we go to, Steve, can you find an example of us using our invoker?
So, right now,
Like just anywhere. I guess you can do apply changes maybe.
let's just show them. So, we use a DLL for our command design pattern. So, our different class functions are here from the C++ side. So, whenever we need to invoke our command design pattern, we use any one of these functions, and an example of it is in what's it called? Apply changes, and in apply changes here, we just do some basic error checking, and then when we're done, we apply, we get the string item here. This we want to check, and then if they're not like duplicate keys, then we're going to change the key, and these are the functions right here. So these will set the key to change key and the new key to change, and then change key invokes our command change key on the C++ side. The change key binary right here. This is an example of our command design pattern right here. Is there anything else you want to add for command?
We can just basically
show them now.
Like show them the code, I guess. So there you saw where we're using our invoker to switch back to C++. Okay. So switch to like I guess change key or one of them. Okay, so here's our wrapper where you can see the same different set of functions that you saw at the top of our previous class. So these are basically what we're calling here, and those connect to our concrete commands. So that those would be the functions that are in reset all keys and change keys. And then I'm gonna show what. Oh no.
What else do you want to show before we show?
No, I was just gonna show like the whole thing. So like switch over to, I guess, reset all keys or change. Okay, so here you can see our input request, and we're sending in the input value, and then that's going to connect to our input request CPP. So hop over there, and here you can see where we have all our values for the key bindings stored here. So we have the default keys, and we have the key bindings that are being changed here.
Anything else you want to show on the C++ side, or?
I guess it's mostly self-explanatory, I guess.
Okay.
So yeah, so that's fine.
Just gonna
You
show.
can show the example of it happening. Yeah.
So, in order to massive amount of trees, we'll get to that shortly. So basically in here, if we want to change a key to say move forward Y, we just apply changes, and that invokes our command to change key. So that change key command gets evoked here, and see, as you see, it's updated here. It's hard to show in game, but now I'm pressing Y and moving forward.
We'll show a better example later on.
Yeah. This leads to our flight rate design pattern, which is what you will be seeing because we spawned a million trees. The flight rate design pattern, we coded on C# side because we needed use of a lot of the Unity mono behavior stuff, and it's like basically loading mesh and stuff. You would have to code your own C++, basically class that actually reads C# scripts. I did research on it, so it was much easier just to code on C# side, and it does help save performance by 3 megabytes when we spawned lots and lots of trees. So on the C# side, we have our tree, which is our abstract class. So these are all the intrinsic values for the flight rate. So this data here is all shared between every tree, but we will never, like for each tree, this is all going to be shared. So like their mesh, their materials, drawing a tree, their colliders, and their rigid body will be all shared by any kind of tree. And then we have a concrete example of this flight rate, which is our oak tree, which then basically we send any extrinsic values like your material count, how many materials you have, to the actual oak tree itself. And then this is basically a lot of Unity stuff that we apply to it. And then we have our tree client. Our client here, this has a pointer here to our, like references our tree that we have, and then all the values that will change based on each tree. So the position, the rotation, scale. So this is the stuff that will change. This is the extrinsic value, and then our intrinsic values of stuff that's shared with all trees here. So basically, the main reason for flight rate here is so that instead of creating multiple instances that have the same data, we just want to create one instance with the same data and change extrinsic values based on, like, it could be color, anything like that, but in our case, we're just changing the position, rotation, and scale of our trees. And so basically the tree factory here, when we use our client, we basically say, oh, we're going to check our dictionary to see if the tree exists, and if it doesn't, we're going to create a new tree and add it to our dictionary. But if it doesn't exist, like if it does exist, we're just going to return a reference to that tree in our tree. This in our tree factory. This allows us to only have one instance created for objects that we're going to use multiple times, and that's the main reason for flight rate pattern. This allows us to load meshes, material stuff only once, and never have to continuously load it when we don't need to. So our client is our tree spawner here. This is where we will be doing the testing. This creates the tree client and instantiates it based on the Unity game objects, and this is the test without the fly rate. So it's testing without the fly rate here. It just creates the same game object multiple different times with loading the textures, the components, and everything that we do in our actual flight rate pattern. So I'm gonna show, we're gonna spawn 10,000 trees. and I'm going to show with Unity Profiler what happens. So, a second. So, right now we're testing without the flight rate pattern with 10,000 trees. So without 10,000 trees, so they're created at start, and this does, the profiler doesn't read memory until it draws everything in scene. So at the start here is where you want to read the most data for creating objects. So in Unity, the mono means the heap, what's stored on the heap. So basically, the memory stored on the heap right now is 10.1 megabytes for the non-flight rate. And you can see the allocation per frame and different like materials and how much they've loaded and seen based on the non-flight rate pattern. So this is 10.1 megabytes here. And then when we use flight rate pattern,
Go back, Steve. It's all
okay,
commented out.
reverse, thank you. So now if I load this again,
And it doesn't clash.
Unity won't crash it. It takes time. Responding to message.
Oh, there we go. Did you pause it?
Yeah, I did. 1 second. I'm not sure Unity needs to catch up and hopefully not crash. Oh, I forgot to clear on play. That's why I'm not seeing the difference. I'm like, why is it? Give me 1 second. Okay, Unity.
Oh no, should we pause OBS?
See, it's not optimized the best because you would do a lot more stuff on the C++ side. Give me 1 second to reopen Unity. Okay, so now we're going to load this again with profiler. Make sure there's 10,000 trees. Now if we load this, we'll see the significant difference of why we use flight rate patterns when we need to instantiate a larger amount of items, like trees, rocks, etc. So basically, we save about 0.4, 0.5 megabytes, which could be, we could allocate even more to our scene, but basically we're saving memory space. If we optimize it a bit more, we could actually show a bigger difference, but we actually save about 4.4 megabytes of data for the flight rate on the heap.
I think we tested earlier with the same data and it saved way more.
Yeah, it does. Give me. Anyways,
Yeah, I should just continue, I guess.
yeah.
Okay, so I guess we'll talk about observer now, or you're gonna continue?
No, that's basically it. Oh,
Okay.
one thing. The reason why we use flight rate in our game is we do not want to create 10,000 instances of trees in a like an open world. Like for example, ours is like a tree logging game where we cut down trees. We don't want to actually create 10,000 instances of the same data. That's going to store so much memory that we rather create one. It will be more effective to use the flight rate for that. Okay, go ahead, Paul.
Okay. So for our game, we using observer, and I guess the player is our subject. Basically, in our game, we have two observers, which one of them observes the score or like the logs that you pick up, and the other observer is the one that checks like if you moved or you picked up this like a certain amount of logs and pops in a uh, pops in an achievement. Uh, was it was it a window, I guess, in this in the game screen, and like their achievement manager. Basically, it we send in the different text and which panel pops up, and that's basically the depending on which event it activates, it will send a different text. And we have scroll down a bit. There in our on notify, we have all our different events like moving achievement unlocked, which hides the panel again. Pick up when we pick up logs. Menu open is when the we activate the menu open achievement. The pros for using the observer is that basically it allows makes code more cleaner, and we are able to separate like different objects to interact with each other, and it doesn't make it like messy, and we don't need to change the like the code in like one area and in the other area. Is that everything or anything more?
So basically, you want your base object to whatever subject you want your observers to follow. In our case, as a player, you want to be able to send single amount of events to each observer that will, based on that event, do something or not do something. But you don't
Mm-hmm.
want you want to make sure it's like separate. Like otherwise you're like instead of doing it separately, like you're gonna have to make more calls to like for
Just
example, achievement manager or score manager. You would when you instantiate them separately, you're actually passing more data calls to them when their event happens instead of just one pass
you
through.
wanna do a quick demo? Just show them like what each does.
Yep, you have to restart Unity.
Remember to lower the amount of trees.
Yeah, just set it to like 100 or 1,000. We don't need that many.
Let me restart Unity because Unity, luckiness.
So, okay. There we go. Start that up.
You can do maximize on play. Or
Okay. So when this game loads, the first achievement is you learn to move. It's basically when the observer checks if you the event when you press a button. So that will send that. The other one is when you collect. Okay, when you press the menu key. When it exits it, it will load the achievement for that, and just do a collect 5 logs. So basically the score counter is also uses observer that keeps in check how many logs you've connected so far. So when you get to 5 logs, it will notify that, hey, I have 5 logs, send this in. We have a couple more, but that's, I guess that's just of it. Yeah, and we have a polar bear pig thingy following you. That Selina made. Good job, Selina.
simple cubes.
Alright, so is
Okay.
that it?
in summary here, just want to.
Analysis profiler.
So we're going to spawn 500 trees.
That's
So yeah, this is at 12.4, and then Specs on 6.4. By the start, starts at 12.4. Flight rate pattern. Non-flight rate pattern.
was that without or with?
I think that was with.
Mm-hmm. Did you save?
Yeah, I did.
Okay.
So, as you see with a small amount of data, it's 12.6 is
Hardly any difference.
a little bit of difference, but you see more since the algorithm's O of n, you over a longer X amount of periods of objects you spawn, you'll see more memory saved. But yeah, that's basically our assignment
Slash game.
/ game.
It's a wood cutting game.
Thank you for your time.
Yes, 100 please. Thanks.